Quantum atom theory is based on two simple ideas. The first is that the wave equation does not just predict what the wave function will be in the future, but that this process represents the forward passage of time itself, photon by photon, or moment by moment. The second idea is that Heisenberg's uncertainty principle is the same uncertainty that we have with any future event. From these two simple ideas, quantum mechanics can be explained in a way that exactly fits in with our everyday experience of nature and time, moving from a known past into an uncertain future. We live in a dynamically evolving universe of continuous change because of the probabilistic nature of the wave-particle duality of light. Only if light waves come in contact with an object will they form new photons of quantized energy that will have a unique position in space and time. In this theory, it is the inward absorption and outward emission of electromagnetic waves that continuously form the arrow of time and the geometry of space-time. The forward momentum of light is continuously creating a blank canvas for the observer that she or he can participate in. The atoms of the observer bond together and then collapse the wave function in unison, forming their own unique future position or reference frame in space and time. It is because the observer can choose when and where to collapse the wave function that we have free will. Life will create its own ripples in the fabric of space-time, forming its own broken symmetry of its own evolutionary path or timeline. It is because this process is at the same rate that light moves that the speed of light between the atoms will always be a universal constant, independent of the motion of the source. This can also explain why light is so beautiful when it strikes an object. It is because we are looking at a moment of pure creation of time and space. In this theory there is no universal time, because the universe is made up of an infinite number of reference frames that have their own proper time relative to their momentum and position. Therefore we are all in a unique position at the center of our own reference frame and can look back in time in all directions at the beauty of the stars. When we look down into the atoms, we can see time-dependent quantum mechanics when the atoms bond together, forming their own beauty of their own symmetry and geometry. But when we zoom in on an individual atom, we find time-independent quantum mechanics, and there is no flow or arrow of time, and all we have is the measurement problem. Each new photon can be measured either as a point in space over a period of time, or as an area of space at a moment in time, but not as both. This is because the observer is always in the moment of now, collapsing the waves of light into new photons of energy that will only be relative to the wavelength of the light and the position and momentum of the observer. In this theory, at the quantum level of the atoms, the moment of now is created by a single photon-electron coupling, creating a wave function of future possibilities. Even the individual atoms of the observer are radiating electromagnetic radiation continuously. The observer will feel this as the continuous flow of time and as the aging process. On the level of everyday objects, the observer will see an infinite number of photon-electron couplings, creating a temporary image, moment by moment, or photon by photon.